Okay, so the next thing that we have here is exercise 3.4. Exercise 3.4, and question number 1 is basically using elementary transformations, meaning row transformations and column transformations and that sort of thing. Find the inverse of each of the matrices if it exists in exercises 1 to 17. So you want to find the inverse of these matrices. So let's say that, for example, you have matrix A, which is basically 1, negative 1, 1, negative 1, 2, and 3. Now, if the inverse of this matrix, if it exists, okay. So now, in order to understand basically what sort of how you go about doing this, so basically you know that if you have some matrix A, you can write it as A times I. That's going to be equal to A again. You can write it as I times A, and that's going to be equal to A again. In any case, you would get the same matrix back. Now, I call this equation number 1, and I call this equation number 2, and for row operations, I'm going to use one of these, and for column operations, I'm going to use one of these, because it's basically not possible to use both of them for row operations, or both of them, or any of them for column operations. The reason is that if I pick, for example, number 1 and write AI is equal to A, so when I basically do matrix multiplication, suppose that I have this matrix here and multiply it by some matrix over here, and you know that matrix multiplication is not commutative, meaning that when I write A times B, this is not necessarily equal to B times A. So the order here is important, which means that, and then the second thing is that when you do matrix multiplication, basically you normally what you do is you choose a row from here and you multiply them by these columns, and you choose another row from here and again take them with these columns, right? So basically in this kind of operation, the matrix on the right, I pick that for column operations, and the matrix on the left, I choose it for row operations, right? Now in this case, if I use this equation for example for row operations, I would do some row operations on this matrix, and then I would do some row operations on, I mean the only matrix that I could do row operations on would be A. And so that's not what I want to do, because if I do row operations on this matrix, then this matrix is going to change. And the logical conclusion of that would be that, for example, this matrix becomes something like B, and this matrix becomes something like I, for example, and then this matrix does not change. So then B times I is equal to I, and that doesn't make any sense I mean, in this situation, that doesn't make any sense for me. And therefore, I use this equation for column operations, and I will tell you why. So, if I use this for column operations, of course, I can do column operations on this matrix. There is no problem with that. And the matrix on the right, I choose it to do column operations. This matrix becomes some other matrix. Call it, for example, B, and I will try to make this a an identity matrix called I, and this remains the same. And then what that means is that the logical conclusion of that is that A times B is equal to I, which means that B is the inverse of A. And that's basically what I want to find. But that's exactly what I want to do. And vice versa, meaning that you can use this for column operations, and then you can use this for row operations. You cannot use this for column, you cannot use this for row operation. Now, what you need to do here is that there is really so suppose that I want to use column, I want to go for row operations. So I will write this as, and there is no way to know whether it's going to work really, but let's try. So using row operations, we have basically, I will use this equation down here, which is IA is equal to A. IA is equal to A. And so I will write my, I basically would be a matrix of order 2, which is 1, 0, 0, 1, right? And A would be basically the matrix that I have, and A would be basically again the matrix A, which is 1, negative 1, 2, and 3, right? Now what I want to do here is that since I want to use row operations, I want to somehow get this matrix to look like this matrix, because I want this equation to become like B times A is equal to I, and therefore from that I want to conclude that basically then B is the inverse of A, and that way I know what is the inverse of A, right? So that means that basically this matrix here has to practically become I. So what sort of row operation do I do so that this matrix, in this matrix, this becomes a 0, this remains a 1, this becomes a 0, and this becomes a 1, right? Okay, so now, well, I did try a couple of things here, and well, I'm not going to waste my time on figuring these out. I'm going to use the solution. I'm going to do every step of this using the solution, and I don't really know what you're going to do in your examinations. Hopefully you're good enough to see all of these different patterns in numbers and doing all of these things. I don't really know what you want to do, but I'm not up for this kind of thing. I will only follow the solutions and finish these exercises. That's what I'm going to do. And in case you need the solutions, of course, you know that you can always go to this website here. Basically, you can go to this website here, tiwariacademy.com, www.tiwariacademy.com, and then you can go and find, for example, basically there is all of these solutions related to mathematics, to physics, to chemistry, to even to Hindi, to all kinds of subjects. They have solutions for. So for example, you can basically go over here, and there is solutions for class 6 through 12, and you can go over here, and these are NCERT book solutions for class 10, for example, or class 12. You can pick class 12, and then you can pick the subject here: offline apps, English, physical education, business studies, biology, chemistry, and for class 6 math, and then you have class 7 math, class 8 math, and so you can basically find almost anything under the planet Earth. You can just simply find it there. But for this sort of thing, there is no way to know what to do, and I don't have that much time to spend on these things, so I'm going to just simply follow the solutions. So basically the matrix, you can write it as 1, negative 1, 2, 3 is equal to 1, 0, 0, 1 times A, and then and I'm going to perform the row operation. I'm going to apply R2 becomes R2 minus 2 times R1, for example. Meaning that row 2, I'm going to take row 2 and subtract from that 2 times R1, meaning that this gives me, for example, let's do it, let's see what happens. So over here I have basically R1 is the same, so 1, 0, and R2 is, for example, 0 minus 2 times 1, which is equal to 0 minus 2, which is equal to negative 2. And then you have, for example, 1 minus 2 times 0, which gives you a 1 again. So you have a 1 here. And then you have your matrix A. Then you have this matrix here. The first row remains the same, 1, negative 1. The second row becomes basically 2 minus 2 times 1, which is equal to 0. And this becomes 3 minus 2 times negative 1, which is equal to 3 plus 2, which is equal to 5. Right? Then what I'm going to do is that I'm going to apply R2. I'm going to apply R2 becomes 1/5 R2. R2 becomes 1/5 R2. So which means that basically R1 remains the same, 1, 0, negative 2, 1, and that is equal times A is equal to 1, negative 1, 0, and 1/5 y is equal to 1. And that is, of course, when you see the solution, everything is simple, but for whatever reason, it's not really find these relationships. And then I'm going to apply R1. R1 becomes R1 plus R2. R1 becomes R1 plus R2, which means that you'll get a 0 over here. So 1 plus negative 2 is equal to negative 1. 0 plus 1 is equal to 1, and then negative 2, 1. And you have times A here. And then over here you have R1 becomes R1 plus R2, which means that 1 plus 0 is equal to 1, and this becomes a 0, 0, 1. And now this is in the form of I, and this matrix times A is equal to I. That means that A inverse is equal to negative 1, 1, negative 2, and 1. That is the inverse of A. Actually, I might have made a mistake here. Let me see here. I said that R2 is the same thing as 1/5 R2. So, no, I made a mistake here. I apologize. So if R2 is equal to, becomes 1/5 R2, that means that I have 1, 0, and then negative 2/5, and then 1/5, and then over here times A is equal to basically 1, negative 1, and then 0, 1. And now if I apply R1 becomes R1 plus R2, then you have basically 1 plus negative 2/5. 1 minus 2/5 is equal to 5/5 minus 2/5, which is equal to 3/5. That is 3/5. And basically 1 plus 1/5 is equal to 1/5. And then you have negative 2/5 here. You have 1/5 here. That becomes your first matrix times A is equal to R1 becomes R1 plus R2. So 1 plus 0 is equal to 1. This becomes 0, 0, 1, which means that basically this is the inverse of A, because this times A is the identity matrix, which means that A inverse is equal to 3/5, 1/5, negative 2/5, and 1/5. Right, so that is basically A inverse. 3/5, 1/5, negative 2/5, and 1/5. I would like to know how you actually do these exercises if you happen to be in class to work, because I actually found absolutely no way to do it. You have to just keep doing this using trial and error, and there is no way to know what to do. So if you have any solutions, and if there is any specific ways that you do in order to deal with these sorts of exercises, please let me know. Thank you. Now, question number 2 is, let's say that your A is equal to 2, 1, 1, 1, 2, 1, 1, 1, and you want to find the inverse of this matrix. Now, it happens that you want to do row operations. To do row operations, I'm going to use this equation. IA is equal to A. IA is equal to A, meaning that I'm using row operations, right? And what that means is that I write IA is equal to A, and I is the same thing as 1, 0, 0, 1, and A is the same thing as A, and A is the same thing as 2, 1, 1, 1. And what that means is that then I will do the I will apply, so 2, 1, 1, 1 is equal to 1, 0, 0, 1 times A, and then if I apply R1 becomes R1 minus R2. Becomes R1 minus R2. We will have, so the row 1 is going to be row 1 minus row 2. So 1 minus 0 is equal to 1. 0 minus 1 is equal to negative 1. And the second row becomes the same. And you have A is equal to 2 minus 1 is equal to 1. 1 minus 1 is equal to 0. And 1, 1. And then if I apply R2 becomes R2 minus R1. If I apply R2 becomes R2 minus R1, we have the R1 basically remains the same, so 1, negative 1. R2 minus R1, 0 minus 1 is negative 1. 1 minus negative 1 is 1 plus 1, which is equal to 2. And that times A is equal to R2 minus R1, so 1 minus 1 is equal to, so 1 and 0 remains the same, and 1 minus 1 is equal to 0, 1 minus 0 is equal to 1. Which means that now this is the identity matrix, which means that the inverse of A is equal to 1, negative 1, negative 1, 2, and that is the inverse of 1, negative 1, negative 1, 2. That is the inverse of A. So question number 3 we have, let's say that you have basically that your A is equal to this matrix 1, 3, 2, 7, 1, 3, 2, 7, and you want to find A inverse. Now here what I see is that they have applied basically row operations, which means that I will write IA is equal to A. I will write IA is equal to A, and therefore what that means is basically I will write IA is equal to A, and so I is the same thing as 1001, and A I write it as it is, and then A is equal to 1327. Then what I will do is apply R2 becomes R2 minus 2 times R1. Then I apply R2 becomes R2 minus 2 times R1. Minus 2 times R1, which means that R1 remains the same, 1, 0, and then R2 is basically 0 minus, for example, here you would have 0 minus 2 times 1, which is equal to negative 2, or 1 minus 2 times 0, which is equal to 1. So you have negative 2 and 1 here, and multiplied by A, and that is equal to row 1 remains the same, 1, 3, and then here you have 2 minus 2 times 1, which is equal to 0, and 7 minus 2 times 3 is equal to 7 minus 6 is equal to 1. You get a 1 over here. And then what I will do is that I will apply R2 becomes R2 minus 3 times R1. Apply R2 becomes R2 minus 3 times R1, which means that R1 remains the same, so 1, 0, and then this becomes, for example, negative 2 minus 3 times 1, which is the same thing as negative 2, negative 3, which is equal to negative 5, and this becomes 1 minus 3 times 0 is equal to 1. So you have negative 5 and 1 times A is equal to R2 minus 3 times R1. So R1 remains the same. R1 remains the same, 1, 3, and 0 minus 3 times 1, it's negative 3, and 1 minus 3 times 3, it's equal to, that's negative 9 plus negative 8. Why did we do this? So 1301, then you get 1001. I think I made a mistake here. So let me do this a step again. So R2 becomes R2 minus 3 times R1, meaning that, and the previous step was basically 1301 is equal to 10 negative 2 1 times A. Okay. Now if I apply R2 becomes R2 minus 3 times R1, I will get basically 10 doesn't change, and R2 is basically, this row is negative 2 minus 3 times 1, is equal to this is supposed to be equal to -5. Okay, so in the solution, it seems that they have made a mistake here. Actually, this is whatever they have written is wrong, meaning that this is not the case. And what you would get here, based on what they have written, is that you would get 7, -3, 7, -3, -2, 1 times A is equal to 1001. 1001. Okay, and we need to figure out what they have done. So if I basically this would be basically then R1. They have to make some changes to R1, and R1 becomes basically R1, well, minus 2 times R2, I suppose. Becomes R1 minus 2 times R2. If I do that, then 3 minus 2 times 1 minus 2 times 1 is equal to 3 minus 2, which is equal to 1, which is actually not the case. This must be a 3, I suppose. So if I write then 3 minus 3 times 1, that is going to give me a 0, which is what I have gotten here. And then 1 minus 3 times 0 is going to give me a 1, which is what I have gotten here. And 1 minus 3 times -2 is equal to, this is positive 6, so I get 7 here. And then basically 0 minus 3 times 1 is equal to -3, which is what we have gotten here. Okay, so so then you have basically R1 becomes R1 minus 3 times R2, and therefore based on this you can say that basically A inverse is the same thing as, is the same matrix as 7, -3, -2, and 1. That's basically all the way up to question number 3. Now the rest of the questions, there is no point for me to do them because, well, there is no point. And there is only one question here. There is only one question, number 18 here, which is a little bit different from those questions, which is matrices A and B will be inverse. A and B will be inverse of each other only if choice A, AB is equal to BA, choice B, basically AB is equal to BA is equal to 0 or O probably. C is AB is equal to 0 or 0, and BA is equal to I, which is not the case. And C, AB is equal to BA is equal to I, which you know that this is the right answer. We already know this, so there is basically no so that is question number 18. Okay, Now, this is enough for me for here. I will, in the next video, we will go through the miscellaneous examples. I'll see you in the next video, and thank you.